Hello students, welcome back to my third video, classification of ligands. First we will do a quick recap on ligands which we will read in our previous video. Ligands, a group of molecules or ions having at least one lone pair of electron eligible for the donation. Example, in Na2COCl4, here cobalt is the central metal and chloride ions are the ligands which are attached with the central metal via coordination bond. In the second example, CrEn2Cl2, here two ethylene diamine and two chloride ion acts as a ligand. Now ligand can be classified on the basis of donor and acceptor properties. First, it can be divided into two types. One is with one or more lone pair electron, another is without lone pair of electron but have pi electron. Example is ethylene or cyclopentadienyl ion, etc. Then the type with one or more lone pair of electron can be further divided into two types. One is with which donate electron to the metal via sigma bond, that is water or ammonia and fluoride ion. Another type is donate electron via sigma bond but accept electron from the central metal via pi bond. Those are P R3, CO, Cn minus, etc. The classification of ligand on the basis of denticity is very important. But first we have to know what is denticity. Denticity refers to the number of donor atom in a single ligand molecule that can bind to the central metal atom in a coordination complex. Now denticity further can be divided into two types, monodentate and polydentate. Polydentate ligands further classified as bidentate, tridentate, etc., which we will learn gradually in this lecture. Monodentate ligand, a ligand with one donor atom to form bond with the central metal atom or ion called monodentate ligand. Example is chloride, bromide, hydroxide, water, ammonia, Cn minus, CO, etc. Let's say CuH2O whole 6 2 plus is the coordination complex. This is the structure where central metal copper 2 plus ion is attached with 6 H2O molecules. Here in H2O ligand, oxygen have lone pair of electron and it will donate at least one lone pair of electron to the copper and form the bond. So here water acts as a monodentate ligand. Now monodentate ligand further classified in ambidentate ligand. What is ambidentate ligand? A certain ligand that can coordinate through either of the two coordination centers. They are called ambidentate ligand. That means the ligand have two donor atoms, but they can act as a donor site either one by one, not two simultaneously. Example is SCN minus NO2 minus CN minus, etc. We will elaborately know about them as follows. Cn minus. Here carbon have negative charge on it. So carbon will act as a donor atom, not nitrogen, because carbon has mm, low electron affinity than nitrogen. So it will easily release this electron to the metal. So carbon is the donor side here. It is the well-known cyanide ion. But sometimes the negative charge lies on the nitrogen. This is the structure when the negative ion will lies on the nitrogen. Then nitrogen will act as a donor side. This is called isocyanide ion. So cyanide can either bind with carbon or nitrogen at a time. So cyanide is a very popular ambidentate ligand. Then NO2 minus, in this case N can donate electron So it will known as nitrito N, and when the O minus this site will act as a donor site, then the ligand will called as a nitrito O. In case of SCN minus sulfur, when sulfur will act as a donor site, it will call thiocyanide, and when nitrogen will act as a donor site, it will call isothiocyanide ion. Now polydentate ligand. A ligand with two or more donor atoms form bond with the central metal atom from more than one donor site called polydentate ligand. When polydentate ligand coordinate to the metal atom from more than one donor site and form the ring with the metal, then it will call chelating ligand, and then complex will be called chelating complex. Polydentate ligand can further classified in different type of ligand. First one is bidentate ligand. By name we know what it means. This ligand, when these ligands have two donor atoms which allow them to bind with the central metal atom simultaneously. Example is ethylene diamine, C2O4 2 minus, DMG, BIPY, etc. Ethylene or EN have structure NH2 CH2 CH2 NH2. Here two nitrogen atoms have lone pair of electron which by which they donate and to the metal and form the bond. By bonding they form a five-membered ring which is a very stable. That's why this type of complex is stable and easily available. Then it comes oxalato. In case of oxalato, this O minus uh, site are act as a donor site. Here they also formed a five-membered ring with the central metal, and this complex is also very stable. The important example of bidentate ligand is dimethyl glyoxine. This is the structure of dimethylglyoxine, but it will lose one proton and become dimethylglyoximate. This is the actual ligand where this two nitrogen atom will act as a donor site. The famous example of dimethylglyoxime complex is the nickel DMG complex. Nickel chloride solution When nickel chloride solution react with DMG solution in presence of ammonia, the rose pink color precipitate we form. This is the nickel DMG complex. Here, this is the nickel DMG structure where two DMG molecule attach with the nickel 2 plus ion, and nitrogen atoms are only act as a binding center, not the oxygen. However, the O minus and hydrogen of the OH group formed a hydrogen bonding with each other. So these complexes are very stable due to the two factors. One is chelation, another is hydrogen bond formation. Next example is bipyridine. Here also these two nitrogen atom with lone pair act as a donor site and form the A5 1 2 3 4 5, a five-membered ring. But there are some exceptions in case of bidentate ligand. First one is thiocyanide ion. We know both that nitrogen and sulfur atom in thiocyanide are eligible for the donation of electron to the metal. So if they simultaneously donate electron to a metal ion, they will form a ring, which is a four-membered ring. And we know four-membered ring are very unstable. So this type of complex are very uncommon, and thiocyanide always act as a monodentate ligand. Similar case arise for hydrogen also. If the two nitrogen of the hydrogen will donate electrons simultaneously to a metal, it will form a three-membered ring. And three-membered ring is very unstable. So this type of complex is also uncommon. Hydrogen will also act as a monodentate ligand or bridging ligand. Next is tridentate ligand, a chelating ligand having three donor atoms capable of attaching with the central metal atom. Example is diethylene tetraamine, triamine, or tripyridine. This is the structure of diethylene triamine. Here the three nitrogen atom with lone pair act as a donor site. Second example is tripyridine or tarpy. Here also three nitrogen atom with lone pair will be act as a donor site. Then tetradentate have four donor site. Example is triethylene tetraamine. Here we can see that these four nitrogen atom will act as a donor site. Next one is pentadentate. Example is tetraethylene pentamine. Here the 5Na nitrogen atom will act as a donor site. Next one is hexadentate. The famous example of hexadentate ligand is EDTA. This is H4 EDTA. After losing the four proton, it will become EDTA and a hexadentate ligand where these four O minus center and two nitrogen center will act as a donor site. This is the structure of a metal attached with one EDTA molecule where it will act as a hexadentate ligand. Now flexidentate ligand. A flexidentate ligand is one that can chelate the metal atom in more than one way. Example is EDTA, cysteine, carbonate, ion, etc. In case of EDTA, first one is H4 EDTA. The whole EDTA molecule have two donor sites. That is means only two nitrogen atom will act as a donor site. Then H3 EDTA means one proton is loosed from H4 EDTA. Then one O minus center and two nitrogen. Then H2 EDTA means two O minus center and nitrogen. That is then density became 4. Then 3O minus center and 2 nitrogen density is 5, and then 4O minus center and 2 nitrogen atom density become 6. The example of EDTA acting as a flexidentate ligand is CaEDTA2 minus. Here EDTA is acting as a hexadentate ligand. MCrOH EDTA. Here EDTA will act as a pentadentate ligand. PDH2O H2 EDTA. Here EDTA will act as a tetradentate ligand. Another example is cysteine. We can see that cysteine have a three donor sites: sulfur, nitrogen, and O minus. So it can act as a tridentate ligand where this all three donor site will act as a donor site and form bond with the metal. It can act as a bidentate ligand also. Then bridging ligand. A bridging ligand is one that can simultaneously bond itself to more than one metal atom. The most important condition of a ligand to become bridging ligand is that it must have at least two lone pair of electrons. Then it can get linked itself to the two at least two metal atoms. Example is OH minus, Cl minus, NH2 minus, hydrogen, carbon monoxide. In this example, we can see that Cl minus ion act as a bridging ligand as well as the monodentate ligand. In this example also, carbon monoxide act as a bridging ligand and monodentate ligand. In this example, NH2 and OH both act as a bridging ligand in the same complex. So, thank you for your attention. See you again in the next video with IUPAC nomenclature of coordination complexes.